Hello, and we're live, everyone. Welcome to this Hedera Technical Community Call for April 2026. Today, we have an outstanding guest from WISeKey, which is a Swiss company working on technology and cybersecurity challenges. And they have an awesome solution built on Hedera. Now, before we dive into that primary topic for the day, there are a few things that I want to cover with you. As always, this is being streamed to multiple channels. It's being recorded. So be sure to share it with your friends, with your colleagues, so that they can also stay up to date on what's happening in the Hedera ecosystem. I also want to remind you about HederaCon. That's happening on May 4th in Miami. So that's only 5 days away, and there's still time to register. So you're going to be seeing topics and talks around tokenization, interoperability, AI and Web3, stablecoins, policy, and so much more. And then in terms of the speakers, you're going to see people from the White House, from Coinbase, from DTCC, Google, Canary Capital, and many of the companies and organizations in the Hedera Council. So it's an event that you cannot miss if you're going to be around in Miami next week. So thought leaders, community members, professionals, and developers are more than welcome to join and attend HederaCon next week. The other thing I want to cover very quickly is the Hedera portal updates. And for those developers tuning in, you also have a playground, a contract builder, and an agent lab that allows you to build agents in minutes or seconds rather than hours. So there have been some really exciting updates throughout the year. And especially today, we just released a new update that allows you to develop in a wallet mode. So now you have two modes to develop in the Hedera Playground. One is with a client, if you're developing backend power applications, or now you can develop with a wallet connector so that you can understand the steps and the implementation of working with Hedera Wallet Connect and the Reown app kit right from the browser without any setup or installation steps. So be sure to check that out if you just go to hedera.com/playground. And one quick reminder is also the upcoming deprecation of local node in favor of solo. So that evolution is happening. And if you're using local node for testing and development, be sure to also check out solo and provide feedback to ensure that meets your needs. All right, so that was the quick housekeeping items. Now, I do want to welcome to the stage Jeremy Pansier from WISeKey. How are you, Jeremy?
Hi, Ed. I'm fine, thank you. Really happy to be here.
Excellent. Thank you for joining us today. All right. Could you start maybe by introducing yourself, also introducing SEALCOIN, WISeKey? What are the problems that you guys are tackling, the challenges that you're solving, and how does blockchain fit into the picture of what you're working on?
Yeah, of course. So, I'm Jérémy Pansier. I am CTO of SEALCOIN, working on the project for more than 2 years. And actually, WISeKey is the group and have sub-companies like there is SEALCOIN, there is WISeSat, you probably heard about it. SEALSQ, that is providing the secure element to secure the devices. And yeah, today I will walk you through how we built the SEALCOIN ecosystem on Hedera. And for the problem we solve, let me set the stage. The core problem SEALCOIN solves is autonomous machine payments. In machine-to-machine environments, devices need to identify themselves, hold keys securely, and settle transactions without a human in the loop every time. Traditional payment rails were designed around human identity, manual approvals, and intermediaries. But that model breaks when you scale to large fleets of devices that need low latency and very small value transactions. So what do we need instead? We need deterministic settlements, we need clear custody boundaries, and we need an onboarding flow that turns a device into a transaction-capable actor without weakening security. And that is exactly the scope of SEALCOIN. making devices transaction capable, auditable, and economically active in a way that is practical for real deployments. So, and why does it require a blockchain? Um, okay, traditional payment rails do not fit well with machine-to-machine economy, mainly due to transaction fees. Uh, Whereas if we use the blockchain, we can benefit of extremely low fees, and especially if we use Hedera, which provides a low and stable fee. If I transact today or in 1 year, I know that the fee will always be uh, 0.1 cents. That makes the cost predictable. So, yeah, I will carry on the presentation, and I will present the flow for this session. So, first, I will walk through the SEALCOIN platform architecture, the specific Hedera services we use, and I'll do a demo. Second, I will explain the role of the software embedded on devices. Sorry. And third, I will briefly show a cross-chain pattern for Hedera token using OFG in layer 0. Fourth, I will talk about the successful POC execution we made involving satellites so that you understand the relationship between SEALCOIN and space communications. Okay, so let me unpack the full stack. Technically, on the product side, we have two main software blocks. The first one is the SEALCOIN platform, which provides the operational environment for device onboarding, identity registration, marketplace coordination, and ecosystem governance. The, the second one is the SEALCOIN Agent, a specialized software application installed directly on participating devices, responsible for managing device identity, executing transaction, and interacting with other agents across the network.
Jeremy, quick question on this slide. I'm sure you'll give us more detail about this architecture, but I'm very curious seeing this um, platform component or this platform layer and the agent layer. How do these two come together? How do they interact with each other?
Yeah, okay, so uh, usually the devices and the platform interact via internet, but in constrained connectivity environments, we propose to expand the connectivity thanks to satellite relays. Uh, don't worry, we'll talk about it more in detail later in the presentation. Um, and yeah, just to uh, go deeper in detail in the architecture, in the platform architecture itself, front-end and back-end responsibilities are very explicit. On the front end, users sign through Wallet Connect. On the back end, we orchestrate transaction preparation, validation, and execution, and we persist operational state. For external integration, we use Ines for PKI certificate operation and WISeID for user authentication. So this separation is important. User custody stays on the user-controlled wallets, while backend controls consistency, policy checks, and post-execution verification. That gives us both security and operational predictability. Okay, then let's start with the SEALCOIN platform. Well, let me map that architecture to Hedera services. We use account create and account update for lifecycle and key management operations. We use token transfer flows for onboarding and payment behavior. We use mirror node reads extensively for balances, account status, token context, and pre-flight chase. And we use contract execute transaction for proof of security smart contract calls like stake, unstake, claim, and withdraw. Okay, and if you want to know why do we choose Hedera, I have I think there is three reasons. The first one is deterministic and predictable settlement behavior. Uh, as I said when I answered your question, Hedera proposes low and stable fees, which matters a lot when you are dealing with machine transactions. And yeah, also Hedera has an enterprise-grade network governance and reliability, which is important when you are deploying infrastructure for industrial environments. Yeah, and also from a developer perspective, the SDK model and transaction lifecycle are very practical for implementation. So it's not only a strategic choice, it's also an implementation fit choice. Yeah. Okay, so now proof of security or POSI. The basic idea is that uh, device transaction activity contributes to a reward model. Two kinds of users can be interested in using POSI. On one side, the participants or token holders who can lock their tokens in a pool, claim rewards, and withdraw according to contract rules. And on the other side, the device operators who can get a free certificate for devices onboarded in pools. Okay, then technically, contract calls are ABI encoded and wrapped in contract execute transaction. Then gas is estimated, and then we apply a safety margin. And we also run chain state sync monitoring, so operational dashboard stay aligned with on-chain outcomes. Okay, the contract you can inspect on a Hedera mainnet is this one. So let's go through it. It's here. Yeah. Okay, so it's a staking like smart contract. And you can see a stake, unstake, claim, and withdraw functions. But I must say that it is not staking because usually when you stake tokens, you earn rewards depending on the amount you staked only. Here, you earn rewards depending on device activity, proportionally of the amount you locked in a pool. Okay, going back to the presentation. It's here. And yeah, a key design principle here is that economic logic lives on chain while orchestration and UX stay off chain. That keeps the trust model transparent while giving a usable product experience. All right. Now the core business flow, device onboarding. The target is to make a device transaction capable while preserving trust and traceability. In practice, the onboarding flow includes key updates, certificate handling, and payment logic. When a device is added, we update account key policy so that device-side operations are authorized according to the expected model. Then certificate pricing is computed, and then transfer execution and certificate issuance are coordinated with rollback and revocation protection in case any substep fails. Another important part is incentives. If a fleet is attached to a valid pool, certificate issuance is free. If it is not in a pool, there is a certificate cost. This is intentional. It aligns operator behavior with network trust participation. So from a product lens, onboarding is not just registration. It is identity, policy, payment capability, and incentive alignment all in one flow. Great. Now we switch from architecture to execution. I will showcase the platform. The sequence you will see is login and wallet linking, POSI participation, fleet creation, and device onboarding with certificate process. Right, let's jump in. You can see two windows. The SEALCOIN platform is on the left and my Kabila wallet extension on the right. Okay. Uh, Also, yeah, I keep both visible on purpose so you can see exactly when a user signature is required and when it is not. Okay, we are on the testnet for the demo. Well, let's start with sign in. Okay, I'm logging in with WISeID, which we use at the identity provider. If you don't have an account, you can sign up. You can create an account through the normal WISeID registration flow, but I'll go directly with an existing one. Okay, so now the first time a user logs in, we ask them to connect their wallet so we can bind wallet context to the profile. This is a one-time step. Okay, here I need to choose this one. So identity is handled by WISeID and custody stays with the external wallet. In other words, WISeID proves who the user is and the wallet proves who can sign on-chain actions. That separation is important for trust boundaries. Okay, we land to the dashboard. Here we show a recap of devices, certificates, and wallet balances. The key point is that these values are not static UI values. They are chain-baked reads. So before users can do any action, we first read current state from Hedera mirror node and only then unlock the relevant operations. You can already see my token and HBAR balances in both the platform and the wallet panel. This read-first approach helps us avoid some failures because we do not try to execute actions against stale assumptions. It also gives users clear visibility into current state before they sign anything. Right, with that context in place, let's move to the POSI flow first. I open the pool detail and here I enter the amount I want to lock. In this case, 10 token. Participating is managed by a smart contract, the POSI smart contract. So this step needs two signatures. The first one is approve allowance. So the contract is authorized to use the amount I just entered. And then the second signature, if it comes here, yeah, it's the contract call itself, the stake function. So this is a good example of how we make multi-step on-chain actions explicit for users. The platform shows participation updated. And yeah, you can also, no. Oh yeah, it have taken a bit more time than expected. You can see here the balance is updated and my participation, which is 10 kites. In the withdraw tab, you can see that my tokens are rewarding. Okay, great. By default, autolock is enabled. That means at the end of a period, tokens can roll into the next cycle automatically. If I want to withdraw, I first need to disable the autolock. this is another smart contract call interaction, the unstake function. So I sign one more transaction. Okay, once confirmed, I can see that my tokens are now locked until this date, about 5 minutes before it becomes withdrawable. This explicit state change is important. The user can immediately understand why withdraw is not available yet. So instead of a hidden delay, we show status and expected unlock behavior. Perfect. While this timer is running, I'll use the time to show device onboarding. I can add a new device here, and I will start by creating fleets because every device belongs to a fleet. Fleet in pool. In this case, okay, I will choose the device type for the fleet. This one will be in a pool. You'll see why just after. And I allocate HBAR and token budget. This creation flow requires two signatures as well. The first one is create account, the account creation for the fleet. And the second one is a token transfer. Here it is. Okay. Now I create a second fleet without selecting a pool. I do this to show the behavior difference later, especially for certificate costs. So fleets with no pool. Not pool. Temperature sensor as well. Data, and I do not select a pool. Okay, I allocate the budget. We also have the account create transaction to sign and the token transfer. All right. With fleets created, I can add a new device. So device A. I select the fleet I want this device belongs to. Let's select the fleet in pool first, and then I fill IP and ports. So as this is a real device, let me just find the IP address for the device. Here, the WebSocket port and HTTP ports. Okay. Yeah, I don't know if you can see, but the device which is running is this one and is embedding a secure element in it. And yeah, it's running the SEALCOIN agent.
That's
So,
amazing. Jeremy, quick
yeah.
pause here just to do a recap. So you created the fleet. You mentioned there's one account, one Hedera account per fleet, and
Yeah.
every device has to be part of a fleet, right?
Mm-hmm.
And then can you explain the connection between devices and the account? Because I understand one fleet has one account, and then what's the relationship or how do devices fit in there?
Yeah, so this will happen just after. Actually, we will add the public key of the device to the fleet account so that the device will be able to spend the token of the fleet account. Okay, so yeah, one last setting you can make is define the geographic location of the device. And next, yeah, Here, because I chosen a fleet that is in pool, you can see that the certificate is free. Uh, but if I go back and select the other fleet, certificate has a cost.
Mm.
Okay. Um, yeah, this is an important behavior. That pricing model nudges user towards pool participation. And yeah, also uh, the certificate is required for secure device-to-device authentication. So I click on request certificate, and here the transaction you'll see is a update account transaction. So this is the time where we add the public key of the device to ask its public key. So we know the public key. We create the update account transaction with this public key, and yeah, I can sign it here. And now we get success. Device added, certificate created and downloaded on the device. After that, notice that I'm not prompted for a second wallet signature for certificate purchase. That payment transfer is signed by the device itself, not by my user wallet. So we keep the user signature scope minimal while still preserving auditable on-chain payment flow. We can still inspect it on the Hedera Explorer. Let me retrieve the Fleet wallet, this one, and I can go to the Explorer, find it. And if I go to the transactions, here you can see the token transfer for the certificate purchase. This one was for the fleet account creation, this one for the token transfer to the fleet account, this one, the update account to add the public key of the device, and this one for the certificate purchase signed by the device itself. Okay, at this point, the device can transact under fleet controls. And when a device transacts, they generate small platform fees. Those fees are routed back to pool participants as reward. So the, the economic loop is participation provides liquidity, device operations generate fees, and rewards return to participants. This is exactly why the pool mechanism and the onboarding flow are connected in one product path. All right, now let's go back to and finish the withdraw flow. I return to pool detail and open the withdraw tab. Now the lock period has passed, so status is withdrawable. If there were fee events during this window, I could also claim rewards. In this run, rewards are 0, so I'll just withdraw the participation amount. Click on withdraw, I approve the contract call. Okay, and wait for confirmation.
Well, that confirms, Jeremy. I think I want to call out a comment that we just saw there on the screen for a second, which is, I think it was from Lucas, but excellent to see how it all comes together and seeing that overall flow and that circular economy that you have
Mhm.
between the device, the participants, and the pools to redistribute those rewards back to those participants. And I do want to call out, how great that implementation is of the account service where you're adding the public key of the device to the account to be able to separate the signing for that account. And I think that's one of the very unique things that maybe it's only possible on Hedera because of that account
Exactly.
service and model. Because
Yeah.
in other networks, you're basically tied with one key, one account, whereas
Mhm.
here you can have one key, one account, but the account is separate, right? You can rotate the key. You can actually have key lists that maybe require all signatures or maybe a threshold of signatures and even
Mhm.
nested keys for an account. So really powerful to see this concept implemented in practice in your solution.
Yeah. This is really useful, and yeah, that's wonderful.
Yeah.
Uh, so okay, uh, so we started with participation, moved through a log state transition, and closed the loop with withdrawal. And that's the full platform cycle I wanted to show live. Sign in, wallet linking operations, pool participation, fleet creation, device onboarding, and certificate issuance. And if you want to inspect the implementation details, the POSI smart contract is publicly available on chain. All right, this is the end of the demo. Uh, Now, let me introduce the second software block, the SEALCOIN Agent. Um, this is the software running directly on each device. Its role is to establish secure communications with the SEALCOIN platform and with other devices, then handle Hedera transactions end to end. On the buyer side, the agent creates and signs the transaction. On the seller side, the agent verifies and executes it. To protect key custody, the agent can integrate secure elements, so private keys stay hardware protected. It also manages device identity with CSR and certificate for trusted device-to-device authentication. So the key idea is simple. Running the SEALCOIN agents, each device becomes transaction capable, authenticated, and policy controlled. Okay, now let me quickly show one more builder relevant component. We implemented OFT smart contracts for kites with layer 0 so the token can move between Hedera and other EVM ecosystems. On the mainnet, the contract is this one, so let's quickly go to it. Here it is. Um, I think it is interesting for this technical call because HTS-based token bridging has Hedera-specific details that developers need to handle carefully, including decimals consistency and transfer boundaries assumptions. Um, the non-Hedera side is relatively standard layer 0 OFT, but the Hedera adapter side is where most implementation-specific work sits. So if you're building multi-chain products and Hedera is one of your settlement domains, these patterns can save significant engineering time. And besides, this one have been audited by an external company, so you can rely on it.
Yeah. Jeremy, I think that's a great distinction and something that I want to double click on, which you articulated very well, right? Like you can transfer maybe from other chains into Hedera if it's a standard ERC, fairly easy to transfer. But yes, if you're transferring something as an HTS token, there is that Hedera adapter available for you that, you have to take into account specific Hedera implementations if you're bringing your asset as an HTS or Hedera token service asset. So great to see that you guys have completed that implementation and are aware of those details.
Thank you.
All right, so
Okay.
I guess
Yeah.
continuing on, if you could tell us what's the interoperability narrative and the cross-chain story, that'd be great for the audience.
Yeah. So actually, the Hedera, the SEALCOIN ecosystem will remain on Hedera. So SEALCOIN platform, SEALCOIN agents will run using the kite token on Hedera. But for users who want to buy the token on their preferred centralized or decentralized crypto exchange on other chains, they can do so, and they can transfer the token to Hedera to use it in the ecosystem. And conversely, if they want to send back the token to other chains to trade it, it's possible. Yeah. Okay, so now let's talk about the POC we have run in space. Let's look at a constrained connectivity scenario. The key idea here is simple. The transport can be intermittent, but trust still has to remain deterministic. In this example, device A has no direct internet access and wants to buy data from device B. So device A creates and signs the transaction locally, then sends that signed intent through the satellite relay path. The satellite forwards the transaction to the destination side, where device B verifies the transaction, executes it, and sends the response back. What matters is that we do not change the trust model when connectivity changes. Signer authorities stay explicit. Signatures remain verifiable and settlement logic stays auditable on Hedera. So even with weak or intermittent connectivity, we preserve transaction integrity end to end. Of course, latency and throughput constraints still exist. We are not bypassing physics, but we can decouple connectivity constraints from transaction trust guarantees. And that is exactly why this architecture is relevant for remote industrial and aerospace use cases. And if you heard about our space drop, this is exactly why it makes sense. It comes from combination of WISeSat and SEALCOIN. WISeSat brings the connectivity layer in constrained environments, and SEALCOIN brings the trust layer. Space Drop is the initiative where that collaboration becomes tangible and where participants can earn bounties and collectible NFTs. All right. If you are building something on Hedera and want to compare implementation patterns, feel free to reach out. Thanks, everyone.
Thank you, Jeremy. I mean, that was really amazing. And there are many questions that I have here. I also want to give the reminder to the community that you can drop your questions or whatever platform you're watching this on, and then we'll take those questions and ask them to Jeremy while we have him here. The other reminder for the community is that, yes, this is being streamed to multiple platforms and recorded. So if you missed the start, you can always go back, rewatch that, or if you want to study any of the particular sections of Jeremy's presentation, you can also do that at your own convenience. So, Jeremy, you mentioned the secure element, and if you could expand or give us more details about how does that hardware level private key, um, like what protection does that give you, and is that crucial or absolutely necessary for IoT payments?
Yeah, okay, so in practice, private keys are generated and stored inside the secure element, and they never leave it. The application sends data to be signed, and only the signature comes back. So even if software on the host is compromised, key extraction is significantly harder. For IoT scale payments, this is critical because each device becomes a transacting actor. That being said, it will depend on use cases. For some devices, secure element can be optional, but in some cases, it's mandatory. I'm thinking about smart meters or even internet routers for which having a secure element is imposed by rules. So, yeah.
Makes a lot of sense. You also showed us that architecture where you have limited connectivity or limited internet access with the satellites. Um, could you speak to some of the challenges or of implementing that architecture and blockchain operations, with satellite connectivity, right? I think you mentioned latency and throughput tend to be primary issues, but what were some of the other challenges in that type of architecture and environment?
Okay, then I think there is two questions here. One is about the hardware constraints, and the other one is about the connectivity constraints. Yeah, let's talk about hardware constraints. So yeah, the main challenges were memory and compute constraints or on very small devices. Um, Full-featured blockchain tooling is often too heavy for these profiles. So we developed a lightweight version of the SEALCOIN Agent, and that implied to implement a lightweight version of the Hedera SDK. Actually, the heaviest component used by the SDK was the gRPC library. So we had to replace it by a handmade serialization, deserialization to be able to even communicate with the Hedera nodes via gRPC. And yeah, when it is about connectivity constraints, yeah, uh, satellite environments had a real constraints. It implied higher latency, intermittent links, and lower bandwidth than terrestrial networks. So you cannot assume synchronous always on transaction flows.
Mm.
Um, and so uh, we also we also had to deal with the transaction expiration time. You know that a transaction expires in I don't know what's the standard time, maybe 3 minutes, but we had to create a specialized transaction. It's possible using the, yeah, you know, modifying the transaction ID. You can set the transaction start date so that it starts in the future, and at reception of the transaction, you can execute it without being after the expiration time. That's the first point. And the second point is about the transaction size itself. To communicate with a satellite, we can only send small payloads. So we had to chunk the transaction and aggregate the chunks in the satellite. So we have a lightweight version of the SEALCOIN agent in the satellite that aggregates the transaction in base 64 and decode it in, yeah, in an object in a transaction, and it's also able to verify the transaction signature. Yeah, that's the main
That's
challenges.
fascinating how you putting all of those components together with the constraints of the architecture and the system that you're designing. And great to hear that things like the SDK and the Hedera capabilities give you also that flexibility. For example, with chunking the transactions,
Mhm.
and you created the agent to be able to regroup that transaction together while being able to verify the signature. So very, very compelling use case. We do have some questions coming in from the audience.
Mhm.
So one relates perhaps to that cross-chain nature, and this first question comes from Sahid. So when is SealCoin available, and on which platform is it available?
Okay, so for the moment, SEALCOIN has been issued on Hedera, but the TG did not happen. Uh, it will be the TG will happen in 2 weeks. Actually, this is really close on the 15th of May. So I cannot reveal the name of the exchange, but yeah, the kite token will be available from that date. And yeah, so we deployed the OFT on several chains. So in addition of Hedera, we have Binance Chain, Base, and Ethereum.
Excellent. Great to hear that that's coming up for the project. So we'll wait for the details from you once those become available. So there's another question here from Derek. How are you handling data validation at the edge before committing to the network, especially with noisy IoT telemetry?
Yeah, okay, so uh, that is an important question for uh, IoT uh, data transactions. Yeah, actually, uh, we do have to deal with data standards to be sure that the data that we receive in response of the transaction is the one expected, and that will depend on each use case. Uh, so uh, we are building the ecosystem to be agnostic. We are building the infrastructure, and for each use case, uh, obviously we have to put in place standards and control the data consistency, integrity, uh, all of that.
Very good. All right. I think that's all the questions that I saw coming through. I do have a question regarding roadmap and next steps. So, Jeremy, if you could let us know, like, what's next for SealCoin on Hedera, and what does the roadmap look like for the next 6 to 12 months? To the extent that you can share.
Yeah, so yeah, actually, we have important features to bring to our products. So for the platform, we want to integrate more marketplaces or adapt them to the upcoming use cases. And for the SEALCOIN agents, we are already rolling out multiple versions so it can run across very different environments, whether it's Windows, Linux, macOS, ESP32, STM32, all of those. Yeah, and yeah, actually, the more exciting one is I repeat myself, but uh, in the very short term, uh, we have the TGE actually on the 15th of May. The Kite token will be listed on a centralized exchange. Yeah.
Excellent. So interesting hearing about adapting to new use cases and perhaps new features. There's this question here from the audience. Is
Mhm.
there plan to use and integrate a card payment, or it will only be via application?
So now the system is designed to work with blockchain and yeah decentralized payments. So payment cards will not be uh, compatible, will not be integrated.
Makes sense, and there's a very interesting point that connects to something that you mentioned at the start of your presentation, which is how blockchain fits in. And I also want to connect this with agents and perhaps machine to machine commerce, because blockchain is almost like the perfect solution to enable machines to be able to access and transact value. Like you're saying, fiat money through cards, it's very difficult for an
Yeah.
agent or a machine to have an identity to open a bank account, but it's extremely easy for an agent or a machine to have its own Hedera or Web3 account and be able to transact value with other agents, with other peer machines, and create these networks that exchange and transfer value. So it's just really amazing to see the use case that you've built that actually materializes that and makes it a reality.
Yeah, exactly. Thank you.
Awesome. All right, everyone. Well, Jeremy, before we close, I just want to pass it over to you. Any last thoughts, any closing thoughts, or anything that you might want to share with the community? Maybe where can they learn more? Just to reiterate, where can they learn more about WISeKey, SealCoin, and some of the other technologies that you guys work on?
Yeah, just what I would say is that if you're building something that is related to our work, don't hesitate to reach out if you have questions about the OFT, about Hedera SDK usage, um, uh, or constrained environment developments. Yeah, don't hesitate to reach out. Happy to answer.
Amazing. Well, Jeremy, thank you so much. We look forward to continuing this conversation. Hopefully, we can have you over in a few weeks or months. You're always welcome to join us and share more with the
Thank
Hedera
you.
ecosystem about the great and interesting things that you guys are building on Hedera. So let's call it a call and have a great rest of the day. Thank you,
Thank you.
Jeremy.
You
Thank you,
too.
everyone.
Bye.